Good morning. Need some help figuring out what a reference angle is, how to find it, degrees or radians? I got you covered. Let's go. So what is a reference angle? How do we find it? And why do we need to use it? Well, let's say you're asked to find the sine of 315 degrees using no calculator, no unit circle, anything like that. So if we draw 315 degrees, that's something like that, right? This right here is 360. So 315 would make it to about there. The reference angle is taking your terminal side and connecting it back to your x-axis. The angle made between your terminal side and your x-axis is called your reference angle, and it will always be an angle between 0 and 90, which means instead of having to memorize the entire unit circle, you can just memorize this first quadrant and then use it for any angle you've got. So let's work this particular problem, and then I'll show you how to work any problem. So 315 degrees, well, that's this amount short of 360. So the way I isolate our reference angle in the fourth quadrant is I take my full 360 and I subtract away the 315, and I'm left with my reference angle. Once I have my reference angle, I go ahead and I calculate the trigonometric function I'm being asked for. So sine of 45 degrees. Well, I've memorized my first quadrant of the unit circle, and I know that sine of 45 degrees is root 2 over 2. And the last thing I do before I give my answer is I check the positive negative of sine in the quadrant where my actual angle is. So I remember my little acronym. All students take calculus, which gives me the positive functions in each quadrant. All of them are positive. Sine and therefore cosecant are positive. Tangent and therefore cotangent are positive. Cosine and therefore secant are positive. So here in my fourth quadrant, it's only cosine and secant that are positive. That means I take my reference angle answer, but I need to note that it is negative in that quadrant. Okay, so that's how to calculate it for this specific theta. Let's look for how to calculate it for any theta. All right, if you're asked to find the cosine of some theta, in your first quadrant, you will simply use theta, right? That's your reference angle. It's your first quadrant angle. If your theta is in the second quadrant, 180 minus that theta gets you your reference angle. In the third quadrant, your theta minus 180 gets you your reference angle. And in your fourth quadrant, as we just did, 360 minus theta gets you your reference angle. Okay, what if that's in radians, not degrees? Easy peasy. Just substitute pi for 180 and 2 pi for 360. Okay, let's find the cosine of 4 pi over 3. Step 1, let's figure out what quadrant it's in. All right, it is not in the first quadrant because 4 pi over 3 is more than a single pi, right? 3 pi over 3 would be 1 pi. That means it is also not in the second quadrant because right here is our 180 or our pi. That means it is in our third quadrant. And we know that in our third quadrant, we go our theta minus pi. So I'm going to take my pi and rewrite it with a denominator of 3, which leaves me with a reference angle of pi over 3. So I am finding cosine of pi over 3. I like to think in degrees, so I go, okay, pi over 3, that's 60 degrees. Cosine of 60 degrees, that's 1/2. And now I check all students take calculus in my third quadrant. Tangent and cotangent are the positive ones, which means my cosine of 4 pi over 3 is negative 1/2. So that's your quick tutorial on reference angles. Play around with that. Leave any questions you have in the comments. Subscribe to my channel so you know when I put out a new video. And as always, keep on mathing.